Hey, what's up, you guys? I'm back um with another podcast. I know it's been a little bit, well, I mean, not really because I just did the one with Ashley and everything, but yeah, today I am solo. I'm going to be talking about something that is very that I believe in a lot. And is something that I stress a lot about. Um, So I wanted to talk about that because, um, yeah. Sorry about that, you guys. My cat was eating and she was making a lot of noise, and um, I could hear her on the microphone. So I had to put her food away because badass is always eating. Anyway, um, so like I was saying, I want to talk about something that is something that I stress about to a lot of people, and I'm a very big advocate for. So today I'm going to be talking about climate change. And if obviously you can already see by the title that this is what I'm going to be talking about, obviously. So obviously, if you don't believe in climate change, that's your opinion. There's so many facts out there that support it. So if you don't believe it, it's kind of just you're just kind of being ignorant, and that's my opinion, because we're all entitled to opinions. So it might not seem obvious at first that there's climate change, but for me personally, I've noticed it, and I believe it. Like it's happening, and yeah, I know there's a lot of people out there that do believe it. Like, don't get me wrong. And a lot of the times it's these dumbass politicians that clearly have their head up their ass so they can't figure it out. But yeah, uh, it's real. So I'm going to be talking about it today. I have some things on my phone that I got from NASA's website. Okay, by the way, so it's like an actual like website, like not some dumb shit like Wikipedia. About facts and different things that are causing global warming and everything. So what I want to like address right now is I think people get confused when you say global warming. I think climate change is more of a understandable phrase, I guess. Um, so I think people get confused with global warming because people think, oh, okay, global warming, that means the whole world is like warming, like, you know, which I feel like climate change is more accurate, because I feel like global warming, like, it just is kind of like one-sided. So for me, what I understand about global warming, or sorry, climate change, is that with climate change, what places are hot right now are going to become cold, and what places are cold right now are going to become hot. That's basically how it's going. So it's basically like a reversal. So it's not like the whole world's just gonna blow up and get hot and all this other shit. So I took some pictures of the website because I don't like writing. It takes too long. I'm lazy as fuck. But I took some pictures of some things off the website that I'm going to read to you guys. Facts about global warming, just a bunch of like information to you guys, and like my opinion on it and everything else. So let's get started after 4 minutes of shit. Um, so um, basically, these are the different like chemicals, different gases that are in the atmosphere, um, that um, in the atmosphere that basically cause the greenhouse effect, which, if you're not aware of that, which I'm sure most of you are, the greenhouse effect is basically like just the heating effect of the Earth. It's basically a lot of CO2, which is carbon dioxide holding all of the gases in the air, in the atmosphere, and it's heating our planet. That's what happened to Venus, and if we're not careful, that's gonna happen to ours too. So yeah, so this is the first part of it. So these are the different gases that are basically causing climate change, and I'm going to read a little bit of definition from each one to kind of explain to you what what it means. So the first one is water vapor, and it says the most abundant greenhouse gas, but importantly, it acts as a feedback to the climate. Water vapor increases as the Earth's atmosphere warms, but so does the possibility of clouds and precipitation, making these some of the most important feedback mechanisms to the greenhouse effect. The second one, and the most abundant, I would say, is carbon dioxide. A minor but very important component of the atmosphere, carbon dioxide is released through a natural process such as precipitation and volcano eruptions, and through human activities such as deforestation, land use changes, and burning fossil fuels. Humans have increased atmospheric CO2 concentration by more than a third since the Industrial Revolution began. This is the most important long-lived forcing of climate change. Sorry about that. So that is another one. And then the next one is methane, hydrocarbon gas produced both through natural sources and human activities, including the decomposition of waste in landfills, agriculture, and especially rice cultivation, as well as ruminant digestion and manure management associated with domestic livestock. On a molecule-for-molecule basis, methane is a far more active greenhouse gas than carbon dioxide, but also one which is much less abundant in the atmosphere. So yeah, like I said, methane is, like I just said, it's more, it's worse than carbon dioxide, but the carbon dioxide is more abundant, so it's like, Jesus, okay. Nitrous oxide, a powerful greenhouse gas produced by soil cultivation practices, especially the use of commercial and organic fertilizers, fossil fuel combustion, nitric acid production, and biomass burning. And then chlorofluorocarbons, synthetic compounds entirely of industrial origin, used in a number of applications but now largely regulated in production and released to the atmosphere by international agreement for their ability to contribute to destruction of the ozone layer. They are also greenhouse gases. So those are the greenhouse gases that are included in that. So these are just like a couple facts and causes and just things that will happen in the future and stuff like that. So it says on average, Earth will become warmer. Some regions may welcome warmer temperatures, but others may not. Warmer conditions will probably lead to more evaporation and precipitation overall, but individual regions will vary. Some drier becoming wetter and others drier. And then it says a stronger greenhouse effect will warm the oceans and partially melt glaciers and other ice. Increasing sea level, ocean water also will expand if it warms, contributing further to sea level rise. Meanwhile, some crops and other plants may respond favorably to increased atmospheric CO2, growing more vigorously and using water more efficiently. At the same time, higher temperatures and shifting climate patterns may change the area where crops grow best and affect the makeup of natural plant communities. And then it says a bit down below that I'm going to read. It says the role of human activity. So this is what it says about, like, obviously what we're doing. And I don't want everyone to think, oh my god, it's just us. Like, we're shit. I mean, yeah, we are, okay, but we're not the only thing that causes CO2. Like, there's other natural things that happen. Like, don't get me wrong, there's other natural things that the planet does that contributes to the greenhouse effect and contributes to climate change, but at the end of the day, we are the ones who cause most of it. So it says here, the industrial activities that our modern civilization depends on have raised atmospheric carbon dioxide levels from 280 parts per million to 400 parts per million in the last 150 years. The panel also includes there's a better than 95% probability that human-produced greenhouse gases such as carbon dioxide, methane, and nitrous oxide have caused much of the observed increase in Earth's temperature over the past 50 years. So, obviously, yeah, we're the main cause, clearly, which is kind of sad, because clearly after the Industrial Revolution, it made it a lot worse. So, let's see. It says here, because I also want to read, basically, because I know, like, there's people trying to make arguments, about how, the sun does stuff and all this stuff, and, like, that is partially true, like, 1% true. So I'm gonna read this little snippet for you. It says, since 1750, the average amount of energy coming from the sun either remained constant or increased slightly. If the warming were caused by a more active sun, then scientists would expect to see warmer temperatures in all layers of the atmosphere. Instead, they observed a cooling in the upper atmosphere and a warming at the surface and in the lower parts of the atmosphere. That's because greenhouse gases are trapping the heat in the lower atmosphere. And climate models that include solar irradiance changes can't reproduce the observed temperatures trend over the past century or more without including a rise in greenhouse gases. So basically, we're the ones who are causing all of this, which I'm sure is not a surprise to anybody that believe in it. And then this is another thing I also want to read. It says, the current warming trend is of particular significance because most of it is extremely likely, greater than 95% probability, to the result of human activity since the mid-20th century, and proceeding at a rate that is unprecedented over decades to millennia. Earth-orbiting satellites and other technological advances have enabled scientists to see the big picture, collecting many different types of information about our planet and its climate on a global scale. This body of data, collected over many years, reveals the signals of a changing climate. The heat-trapping nature of carbon dioxide and other gases was demonstrated in the mid-19th century. Their ability to affect the transfer of infrared energy through the atmosphere is the scientific basis of many instruments flown by NASA. There is no question that increased levels of greenhouse gases must cause the Earth to warm in response. Ice cores drawn from Greenland, Antarctica, and tropical mountain glaciers show that the Earth's climate responds to changes in greenhouse gas levels. Ancient evidence can also be found in tree rings, ocean sediments, coral reefs, and layers of sedimentary rocks. This ancient or paleoclimate evidence reveals that current warming is occurring roughly 10 times faster than the average rate of ice recovery warming. So, there you go. So basically, these are the, things that, if we don't, these are the things that climate change is going to cause. So, here you go. So, it says, and each one of these has, a description about it, so I'm also going to read that, so you guys kind of, can get, more understanding of what it means. So the first one is global temperature rise, obviously. The planet's average surface temperature has risen about 1.62 degrees Fahrenheit 0.9 degrees Celsius since the late 19th century, a change driven largely by increased carbon dioxide and other humans-made emissions into the atmosphere. Most of the warming occurred in the past 35 years, with the 5 warmest years on record taking place since 2010. Not only was 2016 the warmest year on record, but 8 of the 12 months that make up the year, from January through September, with the exception of June, were the warmest on record for those respective months. The second is warming oceans. The oceans have absorbed much of this increased heat, with the top 700 meters, about 2,300 feet of ocean showing warming of more than 0.4 degrees Fahrenheit since 1969. And I know what you guys are maybe thinking, like, these aren't big degrees, right? These are, just, they seem small. But the thing is that with different animals, even us, because yes, we are animals, even though we like to, not think that we are, we are only good enough to handle in a range of so much, before it's really starts to affect us of temperature rising. And we can probably handle it better, but ocean life and other animals can't. So even though it might seem small to you and me, it isn't small to other living creatures. So we just gotta keep that in mind. The next one is shrinking ice sheets. The Greenland and Antarctic ice sheets have decreased in mass. Data from NASA's Gravity Recovery and Climate Experiment show Greenland lost an average of 286 billion tons of ice per year between 1993 and 2016, while Antarctica lost about 127 billion tons of ice per year during the same time period. The rate of Antarctica ice mass loss has tripled in the last decade. So, people might not think that's a big deal, right? But what people fail to understand is that the more that the ice sheets shrink and they get smaller, where do you think all of that water inside of the ice goes? Well, it's not really inside, it's just frozen water. Where do you guys think that goes? It goes back into the ocean. And if the ice sheets are shrinking and glaciers are shrinking and ice is melting, the water is just going to rise. It's just going to get more abundant in the oceans and everywhere else. So where does that lead to? Oh, okay, well, more water means less land. So basically, all these coastal cities, all these coastal states, all these coastal countries are going to be fucked because all of the water is going to rise and basically it's going to eat up all of the land. So there you go. And then there we go. Next one is glacial retreat. Glaciers are retreating almost everywhere around the world, including the Alps, Himalayas, Andes, Rockies, Alaska, and Africa. Decreased snow cover. Satellite observations reveal that the amount of spring snow cover in the northern hemisphere has decreased over the past 5 decades, and the snow is melting earlier. Here we go. Sea level rise. Global sea level rose about 8 inches in the last century. The rate in the last 2 decades, however, has nearly doubled that of the last century and is accelerating slightly every year. So like I said, even though it's only 8 inches, that's still a lot, because the thing is it's if you're building houses and building businesses and all these different buildings at the brink of height, that eventually that water is going to catch up with and it's going to fuck up businesses and everything else. So that's the thing. So that's what we have to keep in mind. Next one is declining Arctic sea ice. Both the extent and thickness of Arctic sea ice has declined rapidly over the last several decades. And then extreme events. The number of record high temperature events in the United States have been increasing, while the number of record low temperature events have been decreasing since 1950. The U.S. has also witnessed increasing numbers of intense rainfall events. And the last one is ocean acidification. And I'm pretty sure this is like a new thing because I don't think people really knew about this, back in the day. So yeah, that's what, So basically, it says, since the beginning of the Industrial Revolution, the acidity of surface ocean waters has increased by about 30%. This increase is a result of humans emitting more carbon dioxide into the atmosphere and hence more being absorbed into the oceans. The amount of carbon dioxide absorbed by the upper layer of oceans is increasing by about 2 billion tons per year. That is fucking ridiculous, people. Like, that is fucked up. Like, we're literally killing everything, including ourselves, and we do not give a fuck. I'm sorry if I sound irritated, but I am. It's fucking stupid. Like, it's so stupid. This whole thing is dumb as shit. Like, we're literally killing our home and ourselves, and we don't give a shit. We're just, it's fine. Like, do people not realize that there are so many other power sources we could be using? There's wind power, water power, solar power. Like, there's all these other fucking things that we could be using that won't kill the earth, and yet we're not doing shit. It's like, y'all are fucking stupid as shit. And if you guys act like, oh my god, well, people lose jobs. No, you're just creating new jobs. So, next argument. Okay, anyway. Next thing I want to read is this. Scientists have high confidence that global temperatures will continue to rise for decades to come, largely due to greenhouse gases produced by human activities. The Intergovernmental Panel on Climate Change, which includes more than 1,300 scientists from the United States and other countries, forecasts a temperature rise of 2.5 to 10 degrees Fahrenheit over the next century. That is fucking ridiculous. According to IPCC, the extent of climate change effects on individual regions will vary over time and with the ability of different societal and environmental systems to mitigate or adapt to change. The IPCC predicts that increase in global mean temperatures of less than 1.8 to 5.4 degrees Fahrenheit, 1 to 3 degrees Celsius above 1990 levels will produce beneficial impacts in some regions and harmful ones in others. Net annual costs will increase over time as global temperatures increase. Taken as a whole, the IPCC states, the range of published evidence indicates that the net damage costs of climate change are likely to be significant and to increase over time. Bam. So these are the some more effects that will come into the future. It says change will continue through this century and beyond. Global climate is projected to continue to change over this century and beyond. The magnitude of climate change beyond the next few decades depends primarily on the amount of heat-trapping gases emitted globally and how sensitive the Earth's climate is to those emissions. The next one is temperatures will continue to rise because human-induced warming is superimposed on a natural varying climate. The temperature rise has not been and will not be uniform or smooth across the country or over time. The next one is frost-free season and growing season will lengthen. The length of the frost-free season and the corresponding growing season has been increasingly nationally since the 1980s, with the largest increases occurring in the western United States, affecting ecosystems and agriculture across the United States. The growing season is projected to continue to lengthen. In a future in which heat-trapping gases emissions continue to grow, increases of a month or more in the lengths of frosting and growing seasons are projected across most of the U.S., and by the end of the century, with slightly smaller increases in the northern Great Plains. The largest increases in the frosting season, more than 8 weeks, are projected for the western U.S., particularly in high elevation and coastal areas. The increases will be considerably smaller if heat-trapping gases emissions are reduced. Changes in precipitation patterns. Average U.S. precipitation has increased since 1900, but some areas have had increase greater than national average, and some areas have had decreases. More winter and spring precipitation is projected for the northern United States and less for the Southwest over the century. Projections of future climate over the U.S. suggest that the recent trend toward increased heavy precipitation events will continue. This trend is projected to occur even in regions where total precipitation is expected to decrease, such as the Southwest. The next one is more droughts and heat waves. Droughts in the Southwest and heat waves, periods of abnormally hot weather lasting days to weeks, everywhere are projected to become more intense, and cold waves less intense everywhere. Summer temperatures are projected to continue rising, and a reduction of soil moisture, which exacerbates heat waves, is projected for much of the western and central U.S. in summer. By the end of the century, what have been once in a 20-year extreme heat days, one-day events have projected to occur every 2 or 3 years over most of the nation. Hurricanes will become stronger and more intense. The intensity, frequency, and duration of North Atlantic hurricanes, as well as frequency in the strongest Category 4 and 5 hurricanes, have all increased since the early 1980s, and relative contributions of human and natural causes to these increases are still uncertain. Hurricane-associated storm intensity and rainfall rates are projected to increase as the climate continues to warm. Sea level will rise 1 to 4 feet by 2100. Global sea level has risen about 8 inches since reliable record keeping in 1880, and is projected to rise another 1 to 4 feet by 2100. This is a result of added water from melting land ice and expansion of seawater as it warms. In the next several decades, storm surges and high tides could combine with sea level rise and land subsidence to further increase flooding in many regions. Sea level rise will continue past 2100 because the oceans take a very long time to respond to warmer conditions at the Earth's surface. Ocean waters will therefore continue to warm, and sea level will continue to rise for many centuries at rates equal to or higher than those of the current century. Okay, next one. Let's see. Okay, and then Arctic likely to become ice-free. The Arctic Ocean is expected to become essentially ice-free in summer before mid-century. That's so depressing, you guys. And the last thing I'm going to read is the U.S. regional effects. So basically, in the U.S., how climate change is going to affect regional areas. So I'm just going to read that. So it says, below are some of the impacts that are currently visible through the U.S. and will continue to affect these regions according to the 3rd and 4th National Climate Assessment Reports released by the U.S. Global Change Research Program. So Northeast. I'm in the Southwest. So, yeah, that's where I'm at in Nevada. So, Northeast. Heat waves, heat downpours, sea level rise pose growing challenges to many aspects of life in the Northeast. Infrastructure, agriculture, fisheries, ecosystems will be increasingly compromised. Many states and cities are beginning to incorporate climate change into their planning. Northwest, changes in the timing of steam flow, reduced water supplies for competing demands. Sea level rise, erosion, inundation, risk to infrastructure, and increasing ocean acidity pose major threats. Increasing wildfire, insect outbreaks, and tree diseases are causing widespread tree die-off. Southeast. Sea level rise poses widespread and continuing threats to the region economy and environment. Extreme heat will affect health, energy, agriculture, and more. Decreased water availability will have economic and environmental impacts. Midwest, extreme heat. Heavy downpours and flooding will affect infrastructure, health, agriculture, forestry, transportation, air and water quality, and more. Climate change will also exacerbate a range of risks to the Great Lakes. And then southwest. Increased heat, drought, and insect outbreaks, all linked to climate change, have increased wildfires, declining water supplies, reduced agriculture yields, health impacts in cities due to heat, and flooding and erosion in coastal areas are additional concerns. So that's basically all that I took, all the pictures I took about those facts. So I know people like, we don't want to think about it because it's scary. We don't want to think about it because it's depressing. And I'm like, no fucking shit, it's scary. No fucking shit, it's depressing. But we have to think about it. We have to talk about it. We have to do something about it. Because if we're just sitting around doing nothing like we have been doing, guess what's gonna happen? Nothing. Nothing's gonna happen, and the shit's just gonna keep going. And just like, I don't want to talk about it. Like, bitch, grow a fucking pair and we'll talk about it. Like, it's not that hard. Like, we need to start doing something, and these fucking dumb fuck politicians need to fucking grow a pair too, because they're the ones who can actually do something about it and do something about it. Like, stop, like, being retarded. So, and I think it's a good idea if celebrities start really being vocal about it, because I feel like celebrities, a lot of people listen to, so if people are vocal about it, people that are higher up and they're vocal about it and they believe in it and they are stressing about it and all this other shit, then maybe more people will actually listen. So this needs to be a thing. I understand there's other things that we need to worry about. I get it. But like I always say, literally all the damn time, if there's no planet, we have nothing to worry about. That's what I'm trying to say. If we keep going the way we're going, we're gonna all die off. I mean, let's just be honest. We're all gonna die off, and then all the shit that we worried about, all these little tiny things, they're not gonna matter because we're not gonna be here. We're killing off so many fucking animals. We're killing off. We're being so ignorant right now. Like, I'm not saying everybody is, because obviously there's a lot of people that are doing things to try to change climate change and, doing things to help out, but we're not doing enough, and we need to do it more drastically and just do something. So yeah, this is my view on it. I know I'm probably intense with it, but it's something that I'm very passionate about, and it's something that needs to be talked about and needs to be done. So like I said, y'all just be vocal about it, do something about it. Just, we need to get to these politicians and tell them, you need to do some shit, because this is ridiculous. Yeah, so I'm gonna end this. I'm going to leave NASA's website in the description below, so you guys can contact them, or if you just need to, look at more information about, climate change. There's so many websites that you guys can look up, so many videos. There's just a lot of information out there. So I hope you guys will educate yourselves and start doing something about climate change, because it's just ridiculous, you guys, and it's just sad to watch. So, but I know this video was kind of intense and serious, but I hope you guys enjoyed it. I hope you enjoyed all the facts and learning and information. I know I did. So if you guys enjoyed, just give it a thumbs up and subscribe, and I will see you in the next one.